This is the second video for section 2.3, 2.3.2, the quotient rule. So just as in the case of products, in general, the derivative of a quotient is not the quotient of the derivatives. So we'll see in class why the following formula follows from the product rule. But if we want to take the derivative of a quotient, well, let's suppose I have two differentiable functions, f and g. Then it is a fact that f over g, is differentiable as long as g of x is not 0. So at any point where g of x is not 0. And how do we calculate it? Well, f over g prime is f prime times g minus g prime times f over g squared. This is the infamous quotient rule. And I will ask that you pay particular attention to the order of things in the numerator, because there's that minus sign between them, which means order matters. So it's the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So let's see a few examples of how to use the quotient rule. Let us differentiate the following function. P of x equals x squared divided by 4x to the fifth minus 2x. So the first thing we need to do is recognize that this is a quotient of two functions. So we will use the quotient rule. So P prime of x, I take the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. And I'm going to use good parentheses so that I make sure that I don't lose a minus sign somewhere. So this is the quotient rule part of it. Now I'm going to actually take the derivative of those two terms in the numerator. So the derivative of x squared is 2x, and then that gets multiplied by 4x to the fifth minus 2x minus x squared, and the derivative of 4x to the fifth minus 2x is 20x to the fourth minus 2. And this is all over 4x to the fifth minus 2x squared. Now, in the first term, I use the power rule. In the second term, I use the difference rule, the constant multiple rule, and the power rule. So don't forget that constant multiple rule. I use that on both terms there. Okay, let's do another example. Let's differentiate h of t is 3 to the t over sine of t plus 1. Again, this is a quotient rule problem. So the derivative is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So there I used my quotient rule. Now, derivative of 3 to the t is 3 to the t natural log 3. And then I leave that times sine t plus 1. Derivative of sine t plus 1 is cosine t. And this is all over sine t plus 1 squared. So in that first term, I use the exponential rule to differentiate 3 to the t. And then in this other term, I use the sum rule, I use the derivative of sine, and I also use the constant rule to take the derivative of sine t plus 1.